Hi everyone, and this is Sandeep. You are watching Samyan's Academy, and in this session we are going to discuss about the light from class 8. Let us start. Then what makes things visible? How we can see the objects? Light helps us to see the objects. We cannot see objects in the dark. Okay, can you see the objects in the dark? No, we cannot see the objects in the dark. Then object becomes visible when light emitted or reflected by it reaches our eyes. Means you are seeing me, means the light falls on me, the reflected light again it reaches to the your eye, and you can visible me, right? Suppose how that objects are visible. Suppose how I am visible to you. The light falls on me, the reflected lights will reach to your eye, then you can visible me. Similarly, how the things are visible? when you enter in the dark room, we cannot see any things, right? When you switch on the light, what will happen? The light falls on that object, the reflected light comes back to your eyes, and then you can see the objects. So in this way you can see the objects. Here you see the torch light falls on this tie, the reflected light again reaches to his eyes, and then he can see this toy. Similarly, here light falls on this battery and the reflected light again reaches to his eyes, then he can see this battery, right? So in this way we can see the objects. Now reflection of light means the bouncing back of light we called as reflection of light. Now when light falls on any polished or shiny surface, what will happen? It changes its direction. So this is called as reflection of light. Means the bouncing back of light we called as reflection of light. When light falls on any shiny surface area, what will happen? It falls on that shiny surface area and it will come back to again to the same plane. So that is we called as reflection, and bouncing back of light we called as reflection. While reflection, the light changes its direction. Okay, while reflection, what happens here? Now you see from this torch the light falls on this shiny surface. Again then what will happen? The reflection light changes its direction and it will project on this white screen. Similarly, this light falls on some angle with this normal, right? Suppose let us assume this light falls on this shiny surface. The reflected light is not coming back to in same direction. Okay, so it is going in other direction by doing same angle, the same angle with the normal. This is we called as normal, right? Now you see what is normal, what is the reflected ray, what is incident ray, what is all these things we can observe in the next slide. The ray of light which strikes the surface is called incident ray. Okay, if ray of light falls on the surface, we called as incident ray, and this is we called as incident ray, right? The ray which is falls on the shiny surface is called as incident ray. What is reflected ray? The ray which comes back after reflection is called as reflected ray. After reflection, one more ray is coming from the shiny surface, right? And this is we called as reflected ray. Now the perpendicular line drawn at point of incidence is called normal. So now you see this is a line, this red color line we called as normal. This is the perpendicular line to the shiny surface, is called as a normal. The angle between the normal and incident ray is called angle of reflection. The angle between the normal and incident. Now you see this is the normal ray and this is the incident ray. Now you see this is the normal ray, right? And this is the incident ray. The angle between these two, we called as incident angle. Okay, the angle between incident ray and the normal is called as angle of incidence. Is it clear? Now what is reflected angle? The angle between this normal and the angle between this reflected ray. Reflected ray is going back, okay, and this is the angle between the normal and the reflected ray we called as angle of reflection. and this is the angle of incidence and the angle of reflection. So what is angle of incidence? The angle between the incident angle and normal ray we called as the angle of incidence. What is the reflected angle? The angle between the normal ray and reflected ray is called as angle of reflection. Okay. Now the angle of incidence is always equal to the angle of reflection. Means these both angle will be always equal. So let us assume the angle of incidence here 30 degrees, and let us assume the angle of incidence is 30 degrees. While after reflection it is going back and making angle with normal rays also 30 degrees. Means the angle of reflection, the angle of incidence always same. Suppose the incident light falls on the metallic surface with this normal, suppose it is making the 60 degrees angle, and while going back also it is making the reflected ray also making same that 60 degrees angle with this normal. The angle of incidence is always equal to the angle of reflection. Is it clear? Now move on to the next one. Okay. Laws of reflection of light. Okay, the laws of reflection of light are, already we discussed that the angle of incidence is always equal to the angle of reflection. The incident ray, the reflected ray and the normal ray at the point of incidence all lie in the same plane. Means same plane means you take any other plane. Let us take the plane. Suppose let us say this is a mobile plane, right? Let us say this is a mobile. The reflected ray, let us assume this is the reflected ray and the normal ray and the angle of reflection, the reflected ray, normal ray and incident ray and this normal both lie on the same plane of the mobile screen. Like that, all lie in the same plane of paper. Means the ray, it is not coming out of the plane, the ray it is not going into the plane. Means all lie in the same plane of the paper. Okay, the incident ray, the reflected ray and the normal at the point of incidence all lie in the same plane. So what are the two laws of the reflection? The angle of incidence is always equal to the angle of reflection. Okay, and the angle of the incident ray, normal ray and reflected ray all lie in the same plane. Now you see here we can observe that now this we have taken one protractor. Now you see the one light is falling on the light is falls on with 20 degrees angle, which is making angle with the normal is 20 degrees. Okay, this is the angle of incidence. That is how much it is, 20 degrees. It is making how much angle with this normal, 20 degrees. Are you able to see this? Now you see this is the 0. This is, let us say this is the normal ray, right? Now you see this is the light which is coming from this torch and it is making angle is how much here, 20 degrees, right? It is falls on this surface, that is we called as incident ray. Now what is happening here? After reflection, the light going in this direction, right? Are you able to see this? The light going in this direction, which is also making how much angle here, 20 degrees angle, and this is we called as a reflected ray. It is coming back from this surface, right? The angle of incidence also making 20 degrees angle here. The angle of reflection also making here how much angle, 20 degrees angle. Means from this experiment we can observe that angle of incidence is always equal to angle of reflection. Is it clear? Right. And now move on to the next. Now image formed by a plane mirror. Okay, daily how you are seeing your face? By using your plane mirror. Then what are the characters of the image of the image formed by a plane mirror? Let us see. The image is erect. Erect means, right, the image is not inverted here. The image is not inverted. Erected means, suppose let us assume one candle is there here. Now you see one candle is there here. Now the candle flame also we can observe above the plane only, right? Chudandi. So sorry, we can observe here the candle flame here, right? Suppose when candle flame is like this, if it is flame like this, and this image we called as an inverted image. Okay, suppose this is an object. Let us assume this is an object. If you see the image like this, means this is the inverted. Okay, can you see like this image in the plane mirror? No, we cannot see like this. How we can see then? We can see like this only, that is erect image only we can see. Okay, this type of images we called as erect images. This is not inverted. Okay, inverted means reverse, erect means the same one we are seeing, right? And the flame is not inverted in position. Okay, then object, the image is same size as the object, means let us assume this a candle size is 5 centimeter and the image also having the same length, that is 5 centimeter only. Okay, the image is the same distance from the mirror as the object is in the front of it. Let us assume the candle is let us assume the here candle is placed 2 centimeter away from this plane mirror. Okay, means where you will get the image, same distance you will get the image after 2 centimeter only from this plane mirror. Behind the mirror where we can see the image, after 2 centimeter, means the distance of the object, the distance of the image always same in plane mirror. Okay, the image is virtual. Virtual means, can you capture on this image on the screen? No, we cannot capture this image on the screen. Why? Because and this image formed behind the mirror, we cannot capture this image on the screen. So the images which we cannot capture on the screen we called as virtual image. Okay, if you capture on the screen, and that images we called as the real images. If you are not capturing on the screen, means that images, that type of images we called as virtual images, and these images we cannot capture on the screen, right? The image is laterally inverted, means your right hand appears as a left hand, your left hand appears as right hand in the mirror, means that is we called as laterally inverted. Right will become left, left will become right. So that is we called as laterally inverted. So we can see the laterally inverted image, the left hand become right, right hand become left. Like that images we called as laterally inverted, right? So what are the images formed by the plane mirror? The image is erect. Erect means it's not inverted, that is up and down, right? The image is same size as the object. The height of the image, the height of the object, both are same. The image is at the same distance from the mirror as the object is in front of it. For example, here we have the we assume that the candle we placed 2 centimeter from this mirror, and also where will you get the image? Image also will get the same 2 centimeter away from the mirror, that is behind the mirror, right? The distance of the object and distance of the image from the surface of the planes, that is same. The image is virtual. Can you capture your image on the screen? No, we cannot capture. So image is formed behind the mirror, like that images we called as virtual images, that we cannot obtain on a screen. The image is laterally inverted. Laterally inverted means the right hand becomes left, left hand becomes right, like that. So like that images we called as laterally inverted images. Okay, is it clear everyone? Now move on to the next one. Next one is regular and diffused irregular reflection. Regular reflection means when parallel rays of light falls on smooth surface, the reflection rays are the parallel. So this is called as regular reflection. Regular reflection forms the image of the objects. Now you see, all lights, all rays falls parallel to each other. Okay, after reflection also it will become parallel. Okay, like these reflections we called as the regular reflections. When parallel rays of a light falls on a smooth surface, the reflected rays also parallel. So like these reflections we called as regular reflection. Only because of these regular reflections only the image is formed. Is it clear? Regular reflection means all rays are parallel incident. After reflection also they are coming back parallelly. Okay, the reflected rays are also parallel to each other. Now when you observe this here, this is a this surface is not plain like this. This is a irregular surface. When light falls on this irregular surface, now you see after reflection this reflected rays becomes zigzag. Okay, these are not in the parallel direction. Okay, these are in another way direction. Some is coming like this, some other one is going like this, other one is coming like this. Okay, and these are not parallel. Like these images, like this parallel rays, like this parallel rays here we are not getting. Okay, when parallel rays of light falls on a rough surface, the reflected rays are not parallel. This is called diffused or irregular reflection. Diffused reflection does not form images of the object. Okay, can you get images from these lines? Rays? No, we cannot get. Right? Now move on to the next one. Now this is a multiple images. Okay, have you seen your images on hair salon shop? Like they plane the mirror like this, inclined means they bend some with some angle. Okay, the plane, the mirror inclined with some angle. Inclined means it is having some angle. It's not like this, so they will place like this. Okay, that is we call as a inclined at an angle. When two mirrors are kept inclined at angle, they can together form multiple images. We can see multiple images of ours, right? This is because the image formed by one mirror forms the object for the other image. Okay, when two mirrors, when you place the 45 degrees inclined to each other, how many multiple images we can observe here? 7 multiple images we can observe. Okay, here we have one formula also to calculate the number of images is 360 by theta minus 1, right? So by using this formula, we can calculate this number of images. When you place the two same mirrors with inclined 45 degrees to each other, then how many number of images can form? 7 images we can see. Okay, now you see 360 by 45. 360 by 45 is how much? 360 by 45 minus 1 you do. 360 by 45 you will get 8 here. 8 minus is how much? 7. Okay. Similarly, when you place the object 90 degrees to each other, how many images it can form? How many images we can observe? So when you place the two mirrors 90 degrees to each other, so 0 0 cancel, 9 how many times? 4 times. 4 minus 1, how much it is? 3 times. Okay, that is 4 minus 1 equal to 3. Okay, when you place the 20 degrees to each other, then how many multiple images can form? 120, 360 by 120 is 3, right? 3 minus 1 is 2. Here we can observe 2 images. We can see here 2 multiple images. Okay. When you place the mirrors 180 degrees to each other, only one image we can see here. Okay. Now when you place the in parallel to each other like this, we can see, now you see this is a parallel to each other, so we can see infinite number of multiple images, right? Infinite number of multiple images we can see here. Okay, like that. When two mirrors are kept with some angle, that is we call as inclined. So when two mirrors kept an angle with 30 degrees, then how many images you can get? 30 degrees. When you place the two mirrors with the 30 degrees, you do it's a simple calculation. That is, you have to use this formula to calculate the number of images. Number of images to calculate this, you have to use n equal to 360 by theta minus 1. So I am giving one question. If you place the two mirrors with angle of inclination, so inclined with the 30 degrees angle, then how many images you can get? How many images you can get? Let us see 360 by 30 minus 1. 0 0 cancel. 3 1 is 3, 3 2 is 6. 12 minus 1. 12 minus 1 means how many images we can see here? 11 images we can see. When you place the two mirrors parallel to each other like this, one mirror is here, one mirror is here, so you in between two mirrors you stand there, then we can see the multiple images, infinite images we can see. How many images we can see? Infinite. When you place the two mirrors like this, now you see here we can see the so many infinite images we can observe here, right? When two mirrors are placed parallel to each other, how many multiple images we can see? Infinite. That is infinite, we cannot calculate. So that many numbers of images we can see. When you place the two mirrors 180 degrees inclination, how many images we can see? Only one. 360 means like this. 180 means one plane mirror is like this, another plane mirror is like this. If you place 180 to each other, then how many images we can see? Just only one image we can see. When you place the two mirrors 120 degrees with the inclination, then how many images we can observe here? 360 by 120 is 3. 3 minus 1 is how much? 2. We can observe here 2 images only. Like that, any angle you can take. By using this formula, we can calculate the number of images. N equal to 360 by theta minus 1, where theta is the angle between the two mirrors. Is it clear? Now move on to the next one. Okay, now here we have one experiment, kaleidoscope. A kaleidoscope is a device used to see multiple images of objects. It has three inclined mirrors at an angle of 60 degrees to each other. This arrangement is usually kept in a cylindrical box and has a few pieces of colored glasses kept at one end. Okay, this is a kaleidoscope. So this is a device. So this is we are using to see the multiple images of the objects. You can see when you place the object like this, so it will get multiple. It will get multiple. Like this, if you place one when you place like this some images, colorful images or colorful objects there, then you can see multiple images. We can see like this. So the beautiful images here we can see also. Okay, that is we called as kaleidoscope. Then how we are placing these three mirrors each to each other? Okay, we are placing these mirrors at 60 degrees to each other. How many mirrors you are taking? Three mirrors you are taking. Then how much inclination you are making here? 60 degrees inclination you are making like this. Okay, one mirror to another mirror, just you place the 60 degrees inclination. Okay, and it has three inclined mirrors at an angle of 60 degrees to each other. This arrangement is usually kept in cylindrical box, like this box, cylindrical box, and has a few pieces of colored glasses kept at one end. This is like cylinder box. Inside the cylinder box you have to made like this one arrangement, right? Then when you place some few glass or colored glass or few any papers, colored papers, then we can see the multiple images like this. Okay, so we can see beautiful patterns and designs due to multiple images formed by the mirrors. In this way we can see the multiple images by using the kaleidoscope. What is the angle between the two mirrors we placed here? 60 degrees. Like how many mirrors we are taking here? Three mirrors. So how we are arranging? In cylindrical box like this. You made like this. Again here also by using this arrangement also we can see like these images, or you can make like this also. Okay, now the one colorful object, when you place this placed in the kaleidoscope, then it can multiple like this and it will form one design like this. Okay, the beautiful designs we can see like by using kaleidoscope. Next one, dispersion of light. Have you ever observed the rainbow? Right, the rainbow is having the 7 colors. That how the rainbow is forming? Because of dispersion of sunlight by the water molecules. Okay, before going to that, then what is dispersion of the light? First you have to observe here. Sunlight or white light is a mixture of 7 colors. That white light, what we are coming, what is it is coming from the sunlight which is coming from the sun. It is a white light. It is a combination of how many colors? 7 colors. Okay, VIBGR, that is the colors we called as VIBGR. Then when you pass the sunlight through this prism like this, here we can observe the 7 colors: violet, indigo, blue, green, yellow, orange, red, and the white color split into different 7 colors. The splitting of sunlight, the white light, into 7 different colors is called as dispersion of light. What is the dispersion? The splitting of light into 7 colors is called as dispersion of light. Now see, the splitting up of sunlight or white light into its colors is called as a dispersion of light. When a beam of sunlight is passed through a glass prism, okay, so the beam means the ray of sunlight which is passing through this glass prism, what will happen? And this sunlight split into how many colors? 7 rainbow colors. The colors are violet, indigo, blue, green, yellow, orange, and red. So here we can see the VIBGR: violet, indigo, blue, green, yellow, orange, red. Like this, the sunlight split into 7 colors, which is we called as dispersion of light. Rainbow is caused due to the dispersion of sunlight by water drops in the atmosphere. Then how we are observing the rainbow? When we observe the rainbow, yeah, so after raining, if sunlight is came, at that time we can observe the rainbow, right? So after raining, what will happen? The water molecules which are present in the atmosphere, it acts like a prism, right? Each water molecule act as one prism. Then what will happen? Through that water molecule, when sunlight enters through the water molecules, what will happen? The water molecule disperse the sunlight into how many colors? 7 colors, and form like a rainbow. Okay, rainbow is caused due to the dispersion of sunlight by water drops in the atmosphere. Okay, now we are going to discuss about this, the human eye. The human eye is the sense organ which helps us to see the objects around us. Because our eye only we are able to see the objects around us, right? The eyeball is almost spherical in the shape. What is the shape of the eyeball? Our eyeball is spherical in the shape. Light enters eye through the transparent member called cornea. Have you seen this? This is we called as cornea. Okay, this yellow color rail is there, no? This is we called as cornea. This light enters from here, and light enters through this cornea. Behind the cornea is a muscular structure called iris. Behind the cornea, you see here we can observe some muscles, muscular structure. So that is we called as iris. So this is the iris. Okay, the red color part which is present in our eyes we called as iris, right? The muscle we called as iris, right? Behind the cornea is a muscular structure we called as iris, which has an opening called pupil. Okay, here we can observe one opening is there. This muscle here, some gap is there. Here the blue color muscle is there, no? So in our eye it is look like it's a red color. So this red color muscle has one opening, one entrance slit is there, and this muscle consists one pupil, and this is one lens is there, and this lens we called as eyeball. This is the we called as pupil, right? Which has an opening called pupil. The pupil controls the amount of light entering the eye. Okay, the pupil. So what is the function of the pupil? It controls the amount of light enters into it. Suppose some bright light is falling on your eye, then what will happen? The pupil will get contract, and it allows only some light only into the eye. Okay, suppose if you entered in the dark room, you want to visible the things clearly. So what will happen at that time? The pupil will get enlarged to allow the more rays into it, like that. So the pupil control the amount of light enters into it, right? Now behind the pupil is the eye lens is there. So it is the convex lens which focus the image of the object on the retina. Okay, now you see behind this pupil, and this is a pupil, and behind this pupil we have one lens is there here. And what is the use of this lens? How the lens look like? It is a convex lens, concave, convex. We have the two types of the lens, right? So if it is like this, if the spherical part is like this, then we call it as a convex lens. It is okay. Concave means it is cave like structure. Cave like structure we call it as a concave lens. Okay, our eyeball is look like this. This is we called as a convex lens, and this part we called as convex, and this part we called as concave. Okay, and this is the convex lens. Okay, behind the pupil, and we can see your convex lens, right? It is a convex lens which focuses the image of the object on the retina. What will happen? The light enters to this convex lens, then after entering it, the light just combine and form an image on this retina. Here this is a black color one layer is there, and this is we called as retina. Okay, on retina the image is formed, right? It has a convex lens which focuses the image of the object on the retina. The ciliary muscles helps the eye lens and to focus the image of objects on the retina. Okay, here we have ciliary muscles. The ciliary muscles helps the image. The ciliary muscles helps to form the image on the retina. Okay, the ciliary muscles helps the eye lens and to focus the image of the objects on the retina. So which helps to the eye lens. So which hold the eye lens so that the object, the light coming from the object, so it formed an image on your retina. Okay, now the rods are sensitive. Sorry, the retina has two types of cells called rods and cones. The retina is made up with how many cells? Two cells. What are those? Rods and cones. The rods are sensitive to bright light and colors. The cones are sensitive to dim light. Okay, the retina is made with how many cells? Two cells, rods and cones. Rods are sensitive to bright light, okay, and colors, and the cones are sensitive to the dim light. And here we have the optical nerve, so the which is connected to the retina, and this optical nerve, what it will do? This is we called as sensory nerves. This optical nerve we called as, sorry, optical nerve, yeah, which passes the this image signal through brain. The brain interprets that signal. After that we can see the objects. Okay, the optical nerve carry the sensations to the brain. Okay, then the brain interpret the images. After that we can see the objects clearly. Is it clear, everyone? Okay, and this is about the human eye. Yeah, this is about human eye, right? Now you see defects of vision. Okay, we have the two types of the defects. Some persons can clearly see the closed objects, nearby objects. They cannot see the distant objects. Some persons can see the distant objects, but they cannot see the nearby objects. Like that we have the two defects of our eye. So now let us see about the defects of vision. The normal human eye can see nearby as well as distant objects clearly. The minimum distance at which objects can be seen clearly is 25 centimeter. Now you see, you take one this paper, then you just what you have to do? You take nearer to your eye. You see the letters are more clear when you take up to 25 centimeter distance. More than 25 centimeters, when you move like this, then we cannot see this object. When we cannot see these letters, we cannot see these letters. Okay, at what distance we can see these letters clearly? When you place this paper at 25 centimeter distance, at that distance we can see clearly. Okay, below that 25 centimeters, when you move like this, then we cannot see the letters clearly. Okay, so what is the minimum distance at which objects we can see clearly? That is 25 centimeters. Okay, some persons can see nearby objects clearly but cannot see the distant objects clearly. Some persons can see distant objects clearly but cannot see nearby objects clearly. These defects can be corrected by using suitable corrective lenses. Okay, some persons can see the nearby objects but they cannot see the far objects, distant objects. Some persons can see distant objects but they cannot see the nearby objects. And like these defects we can correct by using some lenses. Okay, how we can correct? Let us see now. The persons who is able to see the nearby objects, now you see here now you see this is the lens, this is the ray diagrams of the eyeballs. Are you able to see this eyeball? Right, now you see when light enters into this eye, then this light they focused here only, means they combined here only, they are not falling on the retina. Okay, then to fall on the retina, what we are doing, we are using this concave lens. Which type of lens we are using? And this is we call as a myopic eye. Myopic eye means most probably the students will get like this defect, myopic defect. Okay, myopic eye. Myopic eye means they can see nearby objects but they cannot see the far objects. When students sit on last bench and the student who is suffered with the myopic defect, he cannot see the board clearly. Okay, so distant objects cannot seen by the students clearly, then who are suffered with this myopic defect. Okay, so what will happen here, the ray which is entering to this eyeball and falls here, and it is not falling on the retina, right? The ray is combined here itself, means before the retina the image is forming. When the image is forming before the retina, can we see the images clearly? No. To falls on these rays on the retina, then what we are using here? We are using this concave lens. Then when light enters before your eye, we are placing one spectacles which is having the concave lens. That concave lens, what it will do, it will just the light after entering the rays from the concave lens, the rays which is coming from the concave lens will merge on the retina. Then he can see the object clearly. Okay, suffering with a myopic defect, they can use concave lens like this. Okay, what that concave lens will do? Concave lens, the rays, then the concave lens, the rays which is coming from the concave lens will merge on the retina. Okay, now these rays are merging on retina. Now you see, are you able to see this diagram? The person who is suffering with the myopic defect, the rays here it is combined, means it is not combined on the retina, right? Here we have the retina, right? This is the retina. Before retina, the rays are combining here, right? By using this concave lens, what we are doing here? By using this concave lens, what it will do? By using this concave lens, the light will go like this and it merge on the retina. Now you see, exactly it is merging on the retina. By using the concave lens, we can correct this defect. Okay, the person who is suffering with the hyperopia means they can see the they cannot see the nearby objects. They can see the far objects or distant objects. Okay, the rays are meeting. Now you see the rays which are coming from the object, they are meeting behind the retina. Now you see, the rays are meeting behind the retina. So in this case also we cannot see the images. Okay, to correct this defect, so what we are using here? We are using the concave lens. Okay, the rays which are coming from the concave lens which are merged on retina. Okay, the rays merge on the retina. Okay, before using the concave lens, what is happening here? The rays are merging behind the retina. Okay, the rays are merging behind the retina. So in this case also we cannot see the objects clearly. Okay, when will you see the objects clearly? When these rays, when it is merged on the retina, at that time only we can see the objects clearly. Okay, to correct these defects, for myopic eye we are using the concave lens. For hyperopia we can for hyperopia defect we are using the convex lens. Is it clear, everyone? Now you see, sometimes in old age people cannot see clearly because the eye lens becomes cloudy. Cloudy means the old age people has having the cataract problem, and now that cloudy surface is forming on their eyeball. That is, with the white color layer is forming on their eyeball. So because of that they cannot see the objects clearly. Sometimes in old age people cannot see clearly because the eye lens becomes cloudy. This defect is called cataract. It can be corrected by removing the eye lens and replacing it with an artificial lens. Okay, those people who are suffering with the cataract problem, so in that case in that case what the doctors are doing, they are replacing the eye lens, or they are using the eye lens, artificial eye lens. Okay, by using that they can see the objects clearly. Or if you remove this white color layer also, they can see the objects clearly. Okay, is it clear? Now move on to the next one. Care of the eyes. Okay, eyes are very important organs to the humans. Then how we can take care about our eyes? If there is any problem of the eyes, have a checkup and use suitable spectacles if advised. Too little and too much light is bad for the eyes. Okay, and do not look at the sun or very bright light directly. If dust particles enter the eye, do not rub the eyes. Wash your eyes with clean water. Always read at a normal distance. Do not read by keeping the book too close to the eyes or keeping it too far also. Okay, keep at the normal distance. Deficiency of vitamin A also causes night blindness. Those who are suffered with this night blindness, they cannot see the objects clearly at the evening time, from the evening time. So take food rich in vitamin A. Right, so so you have to take care like this. So if you are having any problems, and go to the doctor and check your defect of eye and use the suitable spectacles, okay, which are advised by doctor. And the too little and too much light is also bad for the eyes. And don't study with this dim light, and don't study in the dark light also. Dim light and bright light also, both are very dangerous, and use only normal light only. Do not look at the sun or very bright light directly, okay, and don't look at the sun directly, so it will harm to your eyes. And if dust particles fallen on your eyes, and don't rub like this, and you go to the water and just wash with the water, plenty of the water, then it will go. Always read at a normal distance. Then if you keep more distance also, your eye will get strained. If you keep more than less than 25 centimeter distance also, your eyes will get strained, okay. Then keep the book at normal distance. Deficiency of vitamin, okay, so vitamin A is available in fish and carrot. You use like that food to enrich the vitamin A. Now you see here the Braille system is there. Louis Braille, he is a Braille system is a system used by visually challenged persons, means blind persons. Blind persons cannot read letters clearly, right? For them, here some, by touching the letters, they can feel the letters, and they can read like that. Okay. To read and write, here we have the some Braille system is there. So in that, here 63 dot patterns which represents the alphabets. A means single dot, B means two dots, C means like this horizontal two dots, D means the dots placed like this, right? E means the diagonal, F means like this. By touching the dots, they can read these letters, okay. Now this is we called as Braille system. Here we have the 63 dot patterns which represents the alphabet, common words or signs. Okay, the dots are arranged in the cells of 2 vertical rows of 3 dots each. The dots are raised slightly so that the words can be recognized by touching. Okay, by using this Braille lipi, we can blind people can read the letters easily. Okay, and this is your light lesson from class 8. And if you like this video, please subscribe and share and comment, and do not forget to like. Okay, please like, share, comment. Have a nice day. Bye children. Bye.